Hi, I'm Bruce Wellman, and I'm a high school chemistry and engineering teacher. Now, why do I use Spark101 videos? Because in my chemistry class, I strive to have students experience science and engineering, not just read about it or watch other people do science and engineering. But one of the greatest challenges for me is presenting my students with real-world science and engineering problems or challenges that provide an authentic context for applying the concepts that they're learning in class. That's where Spark101 comes in. Spark101 videos allow me to show my students a real-world STEM design challenge through a short video created by an industry partner, which describes a unique problem that a given business faced, the context surrounding that problem, how they eventually solved the problem, and what types of professional pathways their team members pursued to ultimately be employed at that business and a member of the solution team. To help spark some ideas on how to use Spark101 videos and how they could benefit your students, during the remainder of the video, I'm going to walk you through the instructional design process I used this past week to incorporate a Spark101 video into my high school chemistry class. I'm going to show you how I implemented the lesson with students and share some reflections on what I learned about using these videos with my students. I use this Spark101 video on wind turbines as part of my unit on the properties of gases. Now, just before this gas unit, my students had been working to develop their skills in dimensional analysis. So I wanted to create an instructional pathway which wove together the current content of gases with the prior content of dimensional analysis, while highlighting two important cross-cutting concepts: systems and systems models, and patterns. To start my instructional sequence, I wanted to get my students thinking about wind turbines and curious about how they work and are designed. So I identified two short videos from YouTube to use as my lesson openers. Now, the first video was about 2 minutes long, and it shows a large modern wind turbine that's on fire. And I asked students to first write down some initial questions they had about the event that they saw in the video, and then to work as a small group to develop 3 questions that they wanted to know more about this phenomenon. So after the students had been working as a group for a few minutes, I went around the room and had the group share out their top questions, and I showed the students then the second opening video, which is about 3 minutes long. And it was about Savonius vertical axis wind turbines in Iceland. This showed a different design of wind turbines and mentioned a design improvement for high wind conditions so that wind turbines don't, quote, overspin and catch on fire. So the students then spent a few more minutes in their small group discussing the possible causes for the fire they observed in the first video, as well as new questions they had related to wind turbines and conditions under which they operate. After the students discussed the second opening video, I transitioned to the next segment of the lesson by noting the fact that wind turbine designs and placement seem to be impacted by the wind speed at their location. I then posed the question, but how do you measure the speed of the wind? A few of my students had heard of an anemometer, but they couldn't explain exactly how the wind speed was measured. So I gave each student a copy of the anemometer sheet, and the students worked in small groups for the next 15 to 20 minutes to convert the wind speed of a given reading of a homemade anemometer in revolutions per second into miles per hour. At the end of their team problem-solving time, I had students report out their solution steps on large whiteboards so they could do a gallery walk to observe various different solution pathways to arrive at the correct speed in miles per hour. I then transitioned to the part of my lesson where I used the Spark101 video. I made the connection from wind speed data to real-world design decisions and explained the purpose and the structure of the Spark101 video. I then showed the first segment of the video. This is the part where they describe the problem or the design challenge. If you only have a teacher computer with a video projector, you can show the video for the whole class at the same time. I have my students already sitting in their design teams, so when I pause the video for the next part of the activity, students don't need to move to get started on the active learning activity. If you have a device for every student, I suggest you have 4 students in a design team share 2 computers. Now, you may need to invest in some Y-jacks to do this technique, but I want students to listen to the first part of the video as a team rather than in isolation. So from the very first moment they engage with a challenge, they do so as a team. Once the video was paused, I provided each group with a folder containing the 6 images shown in the first part of the video that were used as evidence to support the designer's claim about which of the 5 locations would be the best to place the rooftop wind turbines. Now, students worked in groups to form their own design choice and support their claims through a solidly reasoned description using the evidence provided in the video. After about 10 minutes of the students working in their groups, I asked each student to commit in writing somewhere in their notes with which location they would recommend and what the reasoning was. I then showed the second section of the video where the professional designers explained how they solved the problem and where they recommended to place the rooftop wind turbines. I paused the Spark101 video a second time to allow students to reflect and discuss in teams how their design choice compared to the choice of the professional design team. After about 3 to 4 minutes of student discussion time, I showed the last segment of the Spark101 video. The presenters provide insight into the career pathways that led various members of the design team to work on such problems, as well as connection to other STEM fields used in solving the design challenge. At the close of the video, I wanted students to individually explore one area or concept brought up in the video and create a one-page deeper dive report. I have been working with students to incorporate images into their technical writing, so for their formative assessment of today's learning, I had them create a one-page brief of a topic connected in the video and the design challenge. The brief had to include 2 images that were labeled with figure numbers and had meaningful captions that included proper citation of the images that they used. Now, this is the assignment that I created, but you can create something that fits within your own learning targets and student interests. So I paused at the end of the lesson and I kind of reflected on how students learned and what they got out of it. It was interesting to circulate it around the room and hear the students truly engaging and describing their choices, their design choices, based upon the evidence they suggested. They were all looking at the same evidence, but students saw different things. And for them to have to negotiate as a team where they thought the best place would be. So I really enjoyed using the Spark101 video. It helped provide my students with a connection to what we're learning in our class to the outside real-world challenges.
One thing that I really liked about the video thing was that they were really able to tell you kind of a background, but you were also kind of able to look at stuff yourself and be able to research and figure out everything yourself rather than just being taught it and having to do worksheets and busy work. You were really able to get hands-on with a group and collaborate to figure out what to do.
I really enjoyed how it was a real-world problem and someone who actually worked on the problem was explaining the not only the requirements that they had, but also the steps that they went through to find a solution and how we were asked our opinion or how we would solve it before we were given the answer.
Hopefully now you have a better idea of what the Spark101 videos are and how you could use them in the classroom context. Thank you for watching the video, and I look forward to hearing and reading about how you use Spark101 videos to challenge your students' ability to apply their STEM knowledge for solving real-world challenges.